Hi everybody, hope you're having a wonderful day. We had started talking about nomenclature and we had separated our four categories for names. And last time we talked about covalent naming versus ionic naming. So let's review real quick. Covalent is when you have two or more nonmetals bonded together. Ionic is when you have a metal and a nonmetal. For covalent and ionic naming, for both of them, basically you write the name of the first element that you see. So here barium, aluminum, lithium, here nitrogen, sulfur. Then you write the name of the second element or the second part and end it with IDE. So oxygen would become oxide, fluorine would become fluoride, chlorine would become chloride. Unless it's a polyatomic ion, you write it as is. So this is nitrate, this is bromine, so it would be bromide, this is carbon, so it would be carbide. Then for covalence, you add prefixes to tell you how many atoms there are. So this would be dinitrogen pentoxide because I have 2 nitrogens, 5 oxygens. This would be trisulfur octafluoride. This would be sulfur hexachloride. Whereas with ionic, you do not add the prefixes. You just leave it as is. So today we're going to talk about ionic naming, but then now we have transition metals. And then we're also going to briefly talk about acids. So let's take a closer look at the ionic naming when you have a transition metal. So CuF2 would be copper 2 fluoride. Fe2S3 would be iron 3 sulfide. MnO2, its name is manganese 4 oxide. So it seems like we're doing what we've done before. The rules for ionic compounds, we said start by writing the full name of the metal or your first element. Then write the name of the nonmetal and end it with IDE. Or if it's a polyatomic ion, then just write the name of the polyatomic ion. Now, normally we would just stop there, but it seems like when you have a transition metal, in parentheses you put a Roman numeral. So here it's 2, here it's 3, here it's 4. Can you figure out what that number is? Think about it for a minute. Let's see if you can figure it out. That number is actually the charge of the metal. Transition metals are called transition metals because they transition in their charges. For example, copper can have a +1 or a +2 charge, depending on what compound it's in. Iron can have a +2 or a +3 charge. Manganese can be +2, +4, +5, or +7. So we don't know what the charge of the metal is, and so when we write the name, we need to indicate what the charge is. So please add to your rules for naming ionic compounds. So you start by writing the full name of the metal, you write the name of the nonmetal, end it with IDE, or write the name of the polyatomic ion. So let's add to that a third step. In parentheses, use Roman numerals to indicate the charge of the metal unless the metal is in group 1. Because if it's in group 1, we always know that's going to always be +1. Group 2, because if it's in group 2, we always know that it's +2. It's never going to be a different charge. Or aluminum, zinc, or silver. So if your metal is in group 1, like lithium or sodium or potassium, or if it's in group 2, like calcium or beryllium or strontium, or if it's aluminum or zinc or silver, you do not do this third step. If it's any other metal other than these, then you do need the parentheses with the Roman numerals. And again, the reason you don't need them if you have these is because group 1 is always going to be +1, so we don't need parentheses to indicate what the charge is. We know what it is. If it's in group 2, it's always going to be +2. If it's aluminum, aluminum is always +3. Zinc is always +2, and silver is always +1. So these never change their charges. That's why we don't need the parentheses for them. Any other metal, we would need the parentheses for it. So let's look at these examples, these 3 examples, and see if we can figure this out. How did we know that this copper is copper 2? Well, we know the charge of the fluoride. Each fluoride has a -1 charge. There are 2 fluorines here, so the total negative charge is -2. Now, for a compound to exist, it needs to be neutral. So if my total negative charge is -2, that means my total positive charge is +2. We only have 1 copper, so copper has to be +2 in this case, so that's why we use the Roman numeral 2. Let's look at the next one. Sulfide. Each sulfide is a -2 charge. We have 3 of them, so that's a total negative charge of -6. In order for the compound to be neutral, that means the total positive charge has to be +6. 2 irons are +6, so each iron must be +3. So therefore we put a 3 there in the name. Let's look at the manganese oxide here. Oxide, each oxide is a -2 charge, but there's 2 of them, so the negative total charge is -4. In order for the compound to be neutral, the total positive needs to be +4. There's only 1 manganese that's +4, so each manganese is +4, so hence the +4. So let's practice some of these. So we're going to start by writing the formula. So first we have manganese 2 chloride. This is ionic, so that means it's made up of ions. So you need to make sure that the total positive and the total negative is neutral at the end to make your compound. So manganese is Mn. This tells us that it's +2 charge. Chloride is Cl minus. And so my compound is going to be MnCl2. Let's look at iron 3 sulfate. Iron is Fe. This tells us that it has a +3 charge. Sulfate is SO4 2 minus. So then we would need 2 irons and 3 sulfates. You can always, if you remember, you can cross these and then reduce if you need to. Okay, next one. Tungsten 4 oxide. So tungsten is W. This 4 tells us that that's +4 charge. Oxide is O2 minus. So then it would be WO2. Again, you can look at it, see that that's +4 and that's -2, so you need 2 oxygens. Or you can cross these and then reduce. Next one, chromium 6 carbonate. So chromium is Cr. This tells us that it's 6 plus. Carbonate is CO3 2 minus. So this is 6 plus and 2 minus. So we would need 3 carbonates for every chromium. Again, you can cross these and then reduce B6 to 2, so that's 3 to 1. Last one here, copper 1 sulfite. So copper is Cu. This 1 tells us it's +1 charge. Sulfite is SO3 2 minus. So we would need 2 coppers for every sulfite. Again, you can cross these if you would like. Let's do the opposite. Let's go from the formula to the name. So you write the name of the first element or the metal, so zirconium. You write the name of the second one, end it with IDE, so fluoride. You check, since this is ionic, that your metal is not in group 1, group 2, or aluminum, zinc, or silver. If it's not, then you would need parentheses, and in the parentheses you put Roman numerals to indicate the charge of the metal. Now, how would I know the charge of the metal? Well, you know the charge of fluoride is -1 each. There's 2 of them, so the total negative charge is -2. For the compound to be neutral, the total positive charge has to be +2. I only have 1 zirconium, so it has to be +2, so it's zirconium 2 fluoride. Next one, write the name of the first element, so vanadium. Write the name of the second one with ID unless it's a polyatomic ion, which it is. So if it's a polyatomic ion, you just write its name, so carbonate. And then you check your metal. If it's not aluminum, zinc, or silver, or group 1 or group 2, you need parentheses, and in the parentheses you're going to put the charge of the metal. So let's try to figure out the charge of the metal. Carbonate has a -2 charge. There's 3 carbonates, so the total negative charge is -6. In order for the compound to be neutral, the total positive charge has to be +6. There are 2 vanadiums that are +6 total, so each vanadium needs to be +3. So this is vanadium 3 carbonate. Next one, Mn3PO47. So name of the first one, so manganese. Name of the second one, phosphate. It's a polyatomic ion, so we don't end it with IDE, we just write its name. It's ionic. The metal is not in group 1, group 2, or aluminum, zinc, or silver, so we need parentheses, and there we're going to put the charge of the metal. So your phosphate has a -3 charge. There's 7 phosphates, so that means the total negative is -21. In order for this compound to be neutral, its total positive charge needs to be +21. There are 3 manganeses for a total of +21, so each manganese would be +7. So this is manganese 7 phosphate. Next one, PbS2. So that's lead. That's the name of the first one. Second one, ended with IDE, so that's sulfide. It's ionic. Check that your metal is not group 1, group 2, or aluminum, zinc, or silver. And it's not, so we need parentheses. Each sulfur is -2. There's 2 of them, so that's a total of -4. For the compound to be neutral, you need the total positive to be +4. There's only 1 lead for a total of +4, so each lead is +4. So it's lead 4 sulfide. Last one, V2CrO4. So vanadium again. This is chromate, a polyatomic ion. And you do need parentheses because this is ionic and the metal is not group 1, group 2, or aluminum, zinc, or silver. So chromate, CrO4 2-. So each chromate is -2. There's only 1 chromate, so the negative total is -2. For the compound to be neutral, the total positive has to be +2. There are 2 vanadiums that are +2 total, so each vanadium needs to be +1. So this is vanadium 1 chromate. The last set of rules are for acids. Acids are a little bit more complicated to name. First of all, to know that it's an acid, if you're given the formula will always start with H. That's how you know that it's an acid. So if your formula starts with H, that means it's an acid. So for example, CH4, it has H's, but it's not in the beginning of the formula. That would not be an acid. But if it starts with it, then it's an acid. If you're given the name, you'll know it's an acid because the name ends with acid. The reason why naming acids is a little bit more complicated is because there are actually 3 sets of rules for acids to name them. What it depends on, like we said, an acid starts with an H, and then it has an anion bonded to that hydrogen. And so depending on what the ending of the anion is, that will determine what the name rule is. So let's start with the first one here. HCl is hydrochloric acid. So if you look at HCl, you look at the anion, not the hydrogen, but the anion portion. The name of that anion is chloride. So if the anion ending is "ide," like chloride, then the name becomes hydro something ic acid. For example, it was chloride, so it becomes hydro chloric acid. So "ide" becomes hydroic acid. Let's look at the next one. H2SO4, so SO4 is my anion. SO4 is sulfate. So if your ending is 8, then the name of the acid is ic acid. So basically it's kind of like the first one except without the hydro. So for example, this is sulfate. So it ends with 8, so it becomes sulfuric acid. So 8 becomes ic acid. Last set of rules is if your anion ends with "ite," this is nitrite. If it ends with "ite," then you change the ending to "us" acid. So this was nitrite, so it becomes nitrous acid. So really 3 sets of rules depending on what your anion ends with. If it ends with "ide," it becomes hydroic acid. If it ends with 8, it becomes ic acid. If it ends with "ite," it becomes "us" acid. If you are going from the name going to the formula, even though it's covalent, you actually treat it as if it's ionic. So you actually balance out the charges. For example, here, if I know it's hydrochloric acid, that means I have H+, and then hydroic started with "ide," so it was chloride. So H+, Cl-, so I would need one of each. So it'd be HCl. If I'm doing sulfuric acid, ic acid means it started with 8, so sulfate is SO4 2-. It's an acid, so it has H+. So I have +1 and -2, so I would need 2 hydrogens, so it'd be H2SO4. Nitrous acid, us, means that it started with "ite," so nitrite is NO2-. Acid means that it has H+, so to make that neutral, I'd need one of each, so HNO2. So let's practice some of the acids. So I have hydrofluoric acid. So there's hydro and ic, so that means it started with "ide." So fluoride. Fluoride is F minus. There's an acid, so that means it started with H plus. H plus and F minus, so my formula would be HF. Nitrous acid, we just did that one. Us means that it started with ite. So instead of nitrous, it would be nitrite is what we start with, NO2 minus. It's an acid, so that means it has H pluses. So to make that neutral, you'd use one of each, so HNO2. Phosphoric acid. So ic acid without the hydro means it started with H, so phosphate. So phosphate is PO4, 3 minus. Acid means we have H pluses. So to make that neutral, you'd need 3 hydrogens and 1 phosphate, so it's H3PO4. Now let's go to writing the name. HI. So this is iodide. So if it ends with ide, you start with hydro. And then it would be ic, so iodic acid. So hydroiodic acid. Let's look at the next one. This right here is carbonate. So it becomes ic acid, so it'd be carbonic. Instead of carbonate, it would be carbonic acid. Carbonic acid is basically CO2 and water, so it's like soda. Next one, H2SO3, SO3 sulfite. So if it's ite, you change it to us acid, so sulfurous acid. Okay, this slide shows you basically a review for all the rules for naming. This is available online. If you go on Moodle, you'll see it. I can also make you copies if you would like. But basically what you start with is you figure out first what type of compound it is. It could be covalent or ionic or acid. You know that it's covalent if you have 2 nonmetals bonded together. You know that it's ionic if you have a metal and a nonmetal. You know that it's an acid if you have hydrogen followed by either a nonmetal or basically an anion, any anion, whether it's a nonmetal or a polyatomic ion. So if it's covalent, you start by writing the name of the element on the left side, so basically the first one. Then you write the name of the second one, but end it with IDE. And then you use prefixes for both of them. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So for example, let's say you have S2F6, so that would be disulfur hexa fluoride, for example. Oops, it's a D. For ionic, you start by writing the name of the metal or the first element, basically. You write the name of the non-metal, end it with IDE or the name of the polyatomic ion. And then, this was our third step, but here I put it in the middle. It doesn't really matter what order you put it in. So after the name of the metal, if it's not in group 1 or group 2 or aluminum, zinc, or silver, then you need in parentheses to write the charge of the metal using Roman numerals. So for example, let's say that I have NaF. So you would write the name of the first one, sodium, write the name of the second one, end it with IDE, so fluoride. The metal is in group 1, so that's it, you're done. Let's do another one. How about Cu2SO4? So you would write copper, then you would write sulfate. This is a polyatomic ion, so you don't end it with IDE. The metal is not in group 1, group 2, or aluminum, zinc, or silver, so you need parentheses. You write the charge of the metal there. Sulfate is -2 charge. There's only one sulfate, so the total negative is -2. Total positive then would have to be +2. 2 coppers are +2, so each copper is +1, so it'd be copper 1 sulfate. Then for the acids, you look at the nonmetal. If it ends with 8, then what you do is you write the name of the nonmetal and change 8 to ic, followed by the word acid. So this was nitrate, so it becomes nitric acid. If the nonmetal ends with ite, then you write the name of the nonmetal, but change the ite to us, followed by the word acid. So this is nitrite, it becomes nitrous acid. If the nonmetal ends with ide, you write the prefix hydro, then the name of the nonmetal, and change ide to ic, followed by the word acid. So HCl, this is chloride, so it becomes hydrochloric acid. If you are going from the names to the formula, for covalent, you write the symbols of both metals, and then the number of the atoms is indicated by the prefixes. So if it's di, for example, you put 2. If it's tetra, you put 4, and so on. So that's pretty easy. For the ionic and the acids, you write the symbols of both elements, but then you use the charges to make a neutral compound. So you have to make sure that your charges balance out. So let's put all the rules together and try to name these here. So first one, you're going to write xenon. Write the name of the second one with IDE, fluoride. Check if it's ionic or covalent or a metal, or an acid. This is covalent because they're nonmetals, all of them. So you use prefixes. And so the first one you don't need a prefix for if it's just 1. So you leave it as xenon. 7 is hepta. So it'd be xenon heptafluoride. NH4SO4. The name of the first one is ammonium. The name of the second one is sulfate. This is ionic, so you would need parentheses if you have a metal that's not in group 1, group 2, or aluminum, zinc, or silver. In this case, you don't really have a metal, it's just ammonium, so you leave it as is. So basically, write the name of the first one, write the name of the second one. If it's covalent, you add prefixes. If it's ionic, you add parentheses if you need them. If it's an acid, then it has its own way of naming. Alright, next one. C2H6. So carbon is the name of the first one. Hydride is the name of the second one. This is covalent, so you need prefixes. So it'd be dicarbon hexahydride. Next one is HNO3. This is an acid. This is nitrate, so 8 becomes ic. So it'd be nitric acid. Next one, Fe2C. Name of the first one is iron. Name of the second one is carbide. This says ionic. The metal is not in group 1, group 2, or aluminum, zinc, or silver, so you do need parentheses. Carbon is -4. There's only 1, so the total negative is -4. For the compound to be neutral, the total positive is +4. 2 irons are +4, so each iron is +2. So it's iron 2 carbide. Next one's an acid. It starts with an H. So you look at this. This is bromide. So ide becomes hydroic acid. So this is hydrobromic acid. Next one is AgCN. So first one is silver. CN is cyanide. It's a polyatomic ion. This is ionic. But you don't need parentheses if it's aluminum, zinc, or silver, or group 1 or group 2. This is silver. So that's just this. Silver cyanide. Next one, PbCrO42. So lead is the name of the first one. Chromate is our polyatomic ion here. This is ionic. In this case, you do need parentheses because it's not group 1, group 2, or aluminum, zinc, or silver. Chromate is a -2 charge each. There's 2 chromates, so the total negative is -4. For it to be neutral, the total positive has to be +4. There's only 1 lead, so each one is +4, so it'd be lead 4 chromate. Next one, name of the first one is aluminum. Name of the second one is hydroxide. This is ionic, but you do not need parentheses if it's group 1, group 2, or aluminum, zinc, or silver. So it's just aluminum hydroxide. Next one, name of the first one is vanadium. Name of the second is carbonate. This is ionic, and you do need parentheses because it's not group 1, group 2, or aluminum, zinc, or silver. So we need the charge of the metal here. Carbonate is -2 each. There's 3 carbonates for a total of -6. So the total positive needs to be +6. 2 carbonates are +6. Sorry, 2 vanadiums are +6. So each vanadium needs to be +3. So it's vanadium 3 carbonate. Next one. Name of the first one is sodium. Name of the polyatomic ion there, this is citrate. It's ionic, but you do not need parentheses because this metal is in group 1, so it's just sodium citrate. Now we're going to go from the name to the formula. So sodium selenide. This is ionic, so we need to balance out our charges. So sodium ion is Na+, selenide ion is Se2-, so the formula would be Na2Se. You can switch and reduce if you want to. Next one, dinitrogen trioxide. This is covalent, so no ions here. So nitrogen, but it's dinitrogen, so 2 nitrogens. Oxide is oxygen, but this is tri, so O3, so NO2O3. Zirconium 1 carbonate, this is ionic, so we need to balance out our charges. Zirconium is Zr, this tells us it's +1 charge. Carbonate is CO3 2-. So you can switch and reduce if you'd like. So Zr2CO3. Titanium 4 sulfite. This is ionic, so we need to balance out our charges. Titanium is Ti. This tells us it's +4. Sulfite is SO3 2-. So we can switch and reduce. So it'd be Ti SO3 2. Hydrocyanic acid. This is an acid. We see hydro and ic, so that means it started with ide. So cyanide. Cyanide is Cn-. Acid means it has H+, so it'd be HCN. Copper 2 nitrate, ionic, so we need to balance out our charges. Cu is copper. This tells us that it's +2. Nitrate is NO3-. So again, you can switch and reduce. So CuNO3 2. Silver nitrate. This is also ionic. So we need to balance out our charges. Silver is always +1. Nitrite is NO2-. So +1 -1, so we just need one of each. So AgNO2. Manganese 7 sulfate. Again, ionic, so balance out your charges. So manganese is Mn. This tells us that it's +7. Sulfate is SO4 2-, so let's switch and reduce. So it'd be Mn2 SO4 7. Carbon tetrafluoride. This one's covalent. No ions here. So carbon. And then fluoride is F. And tetra tells us there's 4. So CF4. Ammonium carbide. This is ionic, so we need to balance out our charges. Ammonium ion is NH4 plus. Carbide is C4 minus. So if you switch and reduce, it'd be NH4, 4 of those, and then C. Barium cyanide, ionic, so we need to balance out our charges. Barium is Ba2 plus. Cyanide is Cn minus. Switch and reduce, so BaCN in parentheses 2. Make sure that you put these parentheses. If you write it as BaCN2, that means that you're doubling your nitrogen, not doubling your whole CN or cyanide. So watch out. Okay, last one, chromic acid. That's an acid. So we have H plus. Ic acid means that it started with 8, so chromate is CrO4 2 minus, so switch and reduce, so H2CrO4. I hope this helps. When I come back, we're going to practice a lot of these, and hopefully that will help. Have a wonderful day. I will see you tomorrow.